Hello everyone. Today we are going to start the chapter of multiple integral and it's lecture number 1. In multiple integral we are going to start with the double integral. So if a function f of x or f of xy is being integrated twice, okay, so that means we are taking double integration. Let us consider a case. Let f of xy be a function which is defined, or we can say bounded by a region R. Then the double integral is being represented by R f of xy into dx and dy, or we can say double integral over the region R f of xy dy and dx. Both are correct and it depends upon the value of integral, that is the limits of integral. Okay, so when we are taking double integration we have three type of cases. So the first case is that in which limits of both x and y are constant. Case number 2, in which limit of x is constant whereas limits of y are variable. And the third case is that in which limits of x are variable whereas limits of y are constant. So we will discuss all the three cases one by one with an example. Okay, so starting with case number 1, here limits of x as well as of y are constant, and let us suppose we have x is varying from a to b and y is varying from c to d. So in that case the integral became a to b then c to d f of xy. Since these are the limits of y, so dy first and then dx. So that means here I have to take integration first of all with respect to y, and then we have to take integral with respect to x. Or we can also write it as c to d and then a to b f of xy. Here the limits are of a to b are of x. So first of all we'll take integration with respect to x first of all, and then we take integration with respect to y. It totally depends upon the limits. Okay. Now for this one let us take in question number 1. So question number 1 is we have to evaluate 1 to 2, then 1 to 3 x y square into dx and dy. So clearly the first part, this one, is with respect to x. So that means we have to integrate with respect to x and then we will integrate with respect to y. So when we are integrating with respect to x, so y is to be kept as a constant. So 1 to 2, integration of x will be x square, y square is constant. So integral of x will be x square by 2 within the limits 1 to 3 and dy. So 1 to 2 y square 1 by 2 upper limit. Now 3 square is 9 minus lower limit is 1. 1 square will be 1 into dy. 9 minus 1 8. 8 by 2 will be 4. 4 to be taken out common. 1 to 2 y square and dy. Now we have to integrate with respect to y. So integration of y square will be y cube by 3 within the limit 1 to 2. So 4 by 3. Now upper limit, that is 2. 2 cube will be 8 minus lower limit is 1. I have to substitute instead of y, I have to substitute 1. 1 cube will be 1. So it will be 4 by 3 into 7, that will be 28 by 3. So this is the answer. Now we will consider one more question. So second question of the same type will be, we have to prove that integral 1 to 2 3 to 4 xy plus e raised to power y into dy dx is equal to 3 to 4, 1 to 2 xy plus e raised to power y dx and dy. That means whenever we have constant limits, so order doesn't matter. Okay, so taking from the left hand side, here what we have, integral 1 to 2, the integral 3 to 4 xy plus e raised to power y, then dy and dx. So that means first of all I am taking integration with respect to y. So when I am integrating with respect to y, so x will be kept as a constant. Now x will be a constant, so keep it as it is. Integral of y will be y square by 2 plus e raised to power y, integral of e raised to y will be e raised to power y within the limit 3 to 4 and dx. So it will be 1 to 2, now upper limit. If I substitute instead of y, I have to substitute the value 4. So 4 square will be 16. 16 by 2, that will be 8x plus e raised to power 4, that is upper limit, minus lower limit 3. So if I substitute 3 here, 3 square will be 9, 9 by 2. 9 by 2 of x plus e cube, and then we have dx. So 1 to 2. I am taking all the like terms collectively. So 8 to the 16. 16 minus of 9. So it will be 7. 7 by 2 of x plus e raised to power 4 minus of e cube, and then we have dx. So it will be 7 by 2 is a constant as it is. Integration of x will be x square by 2 plus e raised to power 4 minus e cube into x within the limit 1 to 2. So it will be 7 by 2 to the 4, and upper limit is what? 2. 2 square plus e raised to power 4 minus of e cube into 2. This is the upper limit. Minus lower limit is 1. So 7 by 4 into 1 plus e raised to power 4 minus of e cube into 1. So solving it further, so it will be 7 by 4, 2 square will be 4 plus 2 times e raised to 4 minus 2 times e cube minus 7 by 4 minus e raised to power 4 minus e cube, minus and minus plus e cube. Okay, so 4 times 7 by 4 minus 1 times 7 by 4, so it will be 3 times 7 by 4 plus 2 times e raised to 4 minus 1 times e raised to 4, so it will be e raised to 4 minus 2 times e raised to power cube plus e raised to power cube, so it will be minus e cube. Result will be 7 3 is 21 by 4 plus e raised to power 4 minus of e cube. This is your left hand side. Now we will take with the right hand side. Now on the right hand side, what we are having, 3 to 4, 1 to 2 xy plus e raised to power y into dx and dy. Now we have to integrate with respect to x first, keeping y constant. So this y is constant, so integration of x will be x square by 2 plus, now this is also constant, so e raised to y as it is. Now integration of 1 will be x, so within the limit 1 to 2 and dy. So 3 to 4, now upper limit 2, 2 square will be 4, 4 by 2, that will be 2, 2y plus 2 times e raised to power y minus lower limit 1, so 1 by 2 y plus 1 substituting over here, e raised to power y and dy. So 3 to 4, now I am subtracting 2y minus 1 by 2y, 2 to the 4, 4 minus 1 3, 3 by 2y plus 2 e raised to y minus of e raised to y, so it will be e raised to power y, and then we have dy. So integrating with respect to y now, 3 by 2 integration of y will be y square by 2 plus e raised to power y as it is within the limit 3 to 4. So it will be 3 by 2 to the 4. Now upper limit 4. 4 square will be 16 plus e raised to power 4. This is your upper limit minus lower limit 3. 3 square will be 9. So 3 by 4 into 9 plus e raised to power cube. Now expanding all the brackets. So it will be 16 3s are 48 by 4 plus e raised to power 4 minus 9 3s are 27 by 4 minus e cube. Now 4 will the LCM. 48 minus of 27, that will be 8 minus of 7 1, 4 minus of 2, that will be 2. 21 by 4 plus e raised to power 4 minus e cube. Now check this value and this value, both are the same thing. So that means left hand side is equal to right hand side, and we can say hence proved. Hope it is clear to everyone. In the next lecture or next session, we will start with the case number 2 and case number 3. Thank you.